Good day to you from Outer Galactic. This is the second day of July in 2026. Over here is a diagram you may have seen before, particularly if you have watched the last few videos. This is the strong force curve, although that is ambiguous, and if you look up strong force in Wikipedia, you will eventually find out that it has changed meaning. So in the interests of clarity, not wishing to use an ambiguous term, I've changed the name of this curve from the strong force curve to a more dynamic name, dynamical. It is the curve of binding energy. This shows the force relation between two protons at binding range. It would be collision range in a hadron collider, where this curve no longer applies because of the extraordinary Newtonian force that is added to the proton with relative velocity in a cyclotron, now called a hadron collider, where magnets, that is magnetism, is used to accelerate the proton on a collision course with a cloud of protons, where the odds of two protons colliding are actually rather astronomically small, but if you do it just right, and they know how to do it, you can force two protons to collide. In which case, a number of subparticles, to just give it a name which perhaps the standard modelers would not approve of, because they don't approve of anything except their goddamned mathematics. But those little curlicues and spirals that fly out, some of them split. It even looks like some of them disappear and perhaps come back into existence, which is now a dominant theme in subatomic particle physics. You have an imaginary space that nobody can seem to get a grip on. And this is an ancient space that is all around us. It is imaginary space, and it is extremely difficult to talk about, define, or even conceive because it is imaginary. So is it really there? Is there such a thing as imaginary space? And if so, why are you calling it imaginary? Now, this curve is an extremely simple curve, as you can see at a glance, but you'll notice if you can kind of take on 3D view, it looks like a corkscrew. It's a perfect corkscrew curve. A perfect corkscrew curve. How can I say that it's perfect? It is because, and here we're going to use our handy dandy pointer, which really assists me. I hope it assists you as well. This is about the mid-range of the curve. Here is the nadir. It is important to note, as I do note at the beginning of every video dealing with this curve, that the blue line has no spatial aspect at all, except for one exception right here, where the blue curved line crosses the space line. And if you're not familiar with this kind of a 2D projection, you might balk at that, and I will confess that when I was first trying to get to know the meaning of this diagram, which is ultimately rather simple and then gets rather extraordinarily complex, but that is the nature of subatomic physics. We are dealing with a certain limit going in, which eventually leads us to the Planck scale, the Planck length, and there are a number of Planck units, meaning the smallest measurable unit in that field or space, so however you characterize the enclosing space, or enclosing. In geometry, it's just called an in space. Enclosing means superspace. In other words, we have a surface to the Earth, we have atmosphere, but then there is an enclosing space of essentially relative vacuum all the way to the moon and beyond. So you have two spaces, the space of the Earth, including its atmosphere, which attenuates, and the enclosing space, which is vacuum in a spherical range around the Earth. From our perspective, it does appear to be spherical, simply because the surface of the Earth is spherical, and the gravitational field, therefore, is spherical to that proportion. So everything is spherical from our perspective on Earth. The nature of this projection is such that it is attempting to capture a spherical relationship, that is, between two spheres, and two protons would be conceived as two spheres because they are two particles, and they don't really gyre, although there is a spin component. Spin is not construed as you and I construe it in the subatomic world. So whatever is the case of the spin or angular momentum of a single proton, that is not what we're going to be talking about, although it would be involved as you get towards the proton center. The proton has a center. It is a spatial center, and it is the only actual particle in that respect. And so it would be the discovery of the Democritus atom, which is obviously an ambiguity because the atom, as we now use it, does not mean the proton. But the smallest spatial particle, which in the ancient days, all the way to the very recent historical time, the particle would be a particle of matter. And there's only one such particle in the whole universe by any definition, and that is the proton. The proton has very little relationship to the electron, except when they bind, but an electron by itself is practically antithetical to the proton in its structure. The relationship between the proton and the electron can be computed geometrically, and I cannot claim to have discovered that, except what I did discover is the mathematical underpinning for that relationship. What does this have to do then with two protons? Why did I introduce proton-electron? It is because the atom, as it is now conceived with the Bohr model, which is still correct, it's still used today, it was essentially discovered by Bohr because he introduced the concept of the quantized shell. And there are 7 shells in the naturally occurring elements. The uranium atom has 7 electron shells. The hydrogen atom, at the opposite end of the natural elements, those that occur naturally in the Earth's crust, hydrogen has 1 shell, and that would be obvious because there's only 1 electron. So that is the simplest of the Bohr atoms. In the history of atomicity, on which subject you can actually read a book by that name, by a man named White, W-H-Y-T-E. If you'd like more information, just leave a comment. I'd be happy to supply that information. I may anyway in the description notes. But atomicity is essentially the study of the atom, which you quickly find out has changed meaning. But do we then refer to the proton as the basic constituent of the universe in terms of matter? Yes, it's called atomic weight, and the atomic number is a counting series from 1 to 92. 92 is uranium, and that has 7 electron shells. At the other end of the atomic spectrum, which is linear with counting numbers, these are counting numbers, it goes from 1 to 92, and there is something kind of in between having to do with isotopes, because the nucleus can have neutrons as well as protons. We will not be dealing with that, and indeed we will not be dealing with complex atoms from helium on up to uranium. There are further elements listed in a standard periodic table. Those are called synthetic. They are manufactured in laboratories. Plutonium does not occur in the Earth's crust. We do not find it in nature, but it can be created. So the plutonium and then neptunium, and then there are more, going all the way up to 100 and beyond. Currently, the highest synthetic element is number 116, that is 116. It has a very interesting name, and there are efforts being made to get to 117. We've covered that, but we're not going to be dealing with the periodic table. Essentially, that is chemistry, although at its most elemental level. We're going to be dealing with the simplex hydrogen atom, in which case it has no neutron. If it did have a neutron as well as a proton, it would have a different name. But we just want simplex hydrogen. Ordinarily, when you say hydrogen, that's what you mean. If it has a neutron, it is called deuterium, and it is possible for it to have 2 neutrons, in which case I believe it is called tritium. These can be not so much synthesized as manufactured, so that you can get something called heavy water. You may have heard of that. That has to do with deuterium. Now, this curve is the basic relationship between 2 protons. Why would I have introduced such a simple relationship with a rather extended discussion of the atom in general and the 2 meanings of the word atom? It is because the proton is a unique particle. In one definition, which I much prefer, it is the only particle. There is only one particle in nature. It is the proton for a very specific reason, which I suggest you take to heart because this leads into a discovery vector. The proton is the only spatial particle because it makes a position in space. The electron does not. That has a footnote which has taken us to the furthest realms of the human imagination. We are now going to be talking about imaginary space. Is it real? Because it certainly looks like everywhere we look, whether to the end of the universe, which is what the James Webb Telescope is helping us to explore, we come to an imaginary space called infinity. That has a technical name which you should take to heart, again, because this is authoritative. You need to be following exactly what I say. There is outer spatial infinity. It's really even hard to define what it is because it is imaginary. Outer spatial infinity, the edge of the universe, does not exist. It does not have an edge. And the James Webb Telescope is busy trying to help our poor mathematical scientists to decide if the universe has an edge or not. Currently, the dominant model, according to the white race of mad scientists, is that the universe definitely has an edge. It is called the Big Bang. That is the edge of the universe. After the Big Bang explosion, then the space of the exploder started to expand into non-space. In other words, the universe had no space, but space just appeared and began to penetrate imaginary space. And that's the basis of the Big Bang model. Strictly speaking, it's called the cosmological model. It makes it sound like that's been decided, that there's only one cosmological model. That is, of course, not true, and in fact, the current cosmological model is literally anti-physical. But is it true? It might be. It's really quite hard to decide, except my line of work, my part in science, is not to be uncertain. But if you say that you are certain, according to the scientific process, you must prove what you say. You must do that. The cosmological modelers call that horseshit. They don't believe in the scientific process. What they believe in is their mathematical ledger domain that has driven them all stark
raving mad.
But
are they right? That, again, is extremely difficult to decide. Not just because the model has artificial support from the government and artificial support from
lunatic
mathematicians. That's not the point. The point is, can that model be disproved? But we go too far afield, do we not? You will see that we are not going too far afield at all. Since it has been proved beyond any shadow of a doubt that the universe is spatially infinite. It is infinite. The Big Bang model has been disproved. Except that for now, I've already given you the caveat, the footnotes, and the frank admission that no one, not even myself, is absolutely certain of this, because we're talking about the universe, which already is insane. How in God's name are you going to conceptualize the universe when you don't even know if it has an edge? That's not the main rub. The model says it does have an edge, an impossible singularity. You may be aware of these fancy-dancy, highfalutin, confusing terms. Maybe it's not confusing to you. I hope not, because I can't stop to explain what that is. But the universe, according to the cosmological model, the expanding universe cosmological model, the Big Bang predicates, or is predicated on, depending on your level of insanity, the universe is expanding because of the Big Bang, and the Big Bang is true because the universe is expanding. A circular argument. So that is already highly suspect, but it cannot be disproved. I have attempted to do so, and in fact I have done so, but there is a gigantic footnote. So I'm not trying to be megalomaniac or pretentious or lord it over everybody. That's already been done. We've all had it lorded over us, and the game is over. Science is psychotic. There is no room for cavilling on that issue. To the degree that the cosmological model is considered to be proved, it proves that the human race is absolutely psychotic and will never understand a motherfucking thing. We don't take that approach here, and this curve is going to help us mightily in solving that paradox. I discovered the solution to the paradox of imaginary space. So we have two prime examples of imaginary space, which so far are fully accepted, but then it depends on your model. We do know, as all children know, that the universe is spatially infinite. Actually, that can be disproved mathematically, and I will show you how that is done in this video. I have been leading up to this and promising this video for 4 years. I have attempted to give this video dozens of times in the past 4 years, but it just gets better and better and better. So now you're going to get the creme de la creme up to this cusp, up to this threshold, which I've achieved. I will not be able to go into great detail on many of the definitions which you would naturally solicit as a scientist, because there's an artistic trade-off in communication at this level. Either you're thorough and rigorous, in which case this will be a 7 to 8 hour lecture, or you can be brief and concise to the extreme, in which case this would be a 20-minute video, but I've learned to try to average it out to about an hour. My natural cadence, my natural rhythm is 2 to 3 hours. That's too much for any audience, including myself. I have to review these videos, of course. And I found that an hour is just about 30% over what most people would want, which is about 40 minutes max. 40 minutes is the limit for a human mind at this level. But you're not going to get everything that you would like to get out of what I say unless I try to be both complete, in which case it goes to hours, or condense it to a nutshell, in which case you'll learn almost nothing except by guesswork or just by believing what I say. That would be about 20 minutes. 40 minutes is my goal. I can't do it. When I struggle for 40 minutes, it goes to an hour. So that's enough of the bracketing information to let you know how this is going to be presented. We are now talking about imaginary space. So I've given you one example of imaginary space. It is the edge of the universe. Whether the universe is finite or whether the universe is infinite, either way you say it, there is an imaginary space beyond the edge. Except that for now, I cannot go into detail on what I just said. You're going to have to accept it and try to ride along with me. So that is one example of an imaginary space. It is called outer spatial infinity. That's one example. The other example is depicted on this simple force curve, and I will show you where infinity is at this innermost scale of the universe. The scale metric, that is the scale of the linear spatial separation metric used in science, goes down to femtometers at this scale. The femtometer is 1/quadrillionth of a meter. And you can look that up or spell it out or do it in your head. 1/quadrillionth is 1,000 times more than 1 trillionth, etc., etc. So that is a femtometer, and the femtometer is this distance. Expand this up here. There is 0. Watch, that's a half a femtometer, that's a femtometer. Right there, where the blue line crosses the space line, that is exactly 0.8 femtometers. Now you know it's not exact. It is exact to the definition used in the calculus. It's as precise as you like. And that's as far as we like, because we're hamstrung to be more precise. So it's not as precise as we would like. It's as precise as we can get. It's about 0.8 femtometers is where this blue line, which is the force line, crosses the space line, which is the horizontal line you see. The reason I call that the space line is because this is a 2D projection where space exists exactly and only on this line. Anything above the line or below the line is not space. So what is it if it's not space? It's force. What force? The force that exists between the two protons. So you can see there's only one place where there's 0 force between the two protons. And that's where the blue line crosses the space line. That is the only intersection between the force line and the space line. And at that intersection, which you can see is skewed, it is not a perpendicular angle, because this line shooting up is at an angle where it crosses the space line. So this line, as it's crossing the space line, is called a continuous line. It is a continuous line. This line, the horizontal line, cannot be continuous. A perfectly straight line is not continuous. Except that for now, I cannot explain that. It's in my previous videos, but I will come back to that so that you'll be sure of what I'm saying. The important aspect of this diagram that you must grasp right away is this blue line that is a continuous line, as I'm calling it, except that for now, this continuous line of force does not exist in space. But there is one spot called a point where if a proton is here and the other proton is always at zero, that's how this is constructed. This is called the inertial frame of reference. That is not the proton, that is the center of the proton. That's at 0, 0. This proton being at exactly, we're going to say 0.8 femtometers away from the other proton, their centers are that far apart, they experience no force between them. What do we mean by force? It's either attractive or repulsive. Either the protons are being drawn towards each other or they're being repelled away from each other. This is not the charge relationship. The charge relationship, if you wanted to see where that was, you would have to continue in this direction from left to right, but this is inside the range of the charge force, where instead of repelling, the two protons attract. But you can see that's not entirely true. It depends on how close they are to each other. If there were a proton 3 femtometers away, and its stop action, this is just a snapshot, the inertial proton, which has no velocity, not even relative, that's just the way this is constructed. You can do this, of course. This proton is stationary. That means it has no Newtonian force, which means it has no velocity. It's stationary, called the inertial frame of reference, is the center of that proton. This proton is 3 femtometers away, and now we start action. We start the universe. We start time to see what they're going to do. This proton is conceived as also having no velocity. So this is somewhat artificial, but it's accurate. It's a stop action snapshot of 2 protons 3 femtometers away with no velocity of their own. What happens? As soon as you start time, instantly, without any time lapse at all, as soon as you start time, the proton is already moving. And that is a paradox called the quantum jump. So it starts moving immediately, which is a contradiction. Nothing happens immediately. There's always a time lapse. Not so. Not in this diagram. So the proton is sitting on the spaceline at 3 femtometers. We start action and the proton begins moving toward the other proton at 0, 0. Why? I mean, how do we know that? Because of the blue line. The blue line is below the spaceline. So at the 3 femtometer mark, I want you to see this extremely clearly, so I'm going to expand this, I'm going to enlarge this. You will notice that the blue line does not intersect. It does not intersect the spaceline. How long does that go on? According to this diagram, the way it's drawn, it goes on to infinity. That is false. There's still an electrostatic range. Because if this diagram were strictly true, what this part of the curve shows is that the 2 protons will feel an attractive force all the way to infinity. And that's not true. Protons repel. They do not attract. They repel. But that is an incomplete statement. Both statements are incomplete. So let me fill in the blank. The force relationship between 2 protons depends on their range. So further out, way off the graph, the 2 protons will be found at start action to be repulsive. And if you drew that curve, it would be above the line, above the space line, correct? The long and short of it, although I don't wish to rub this in, is that Wikipedia has a mistaken graph here that is extremely and extraordinarily misleading for the reason I just told you. However, if you simply disregard the fact that this curve is drawn asymptotically to the spaceline, which is not true, and you disregard the fact that it looks like, that is mathematically and geometrically, that the two protons will feel attractive force to infinity, that is untrue. How would you redraw it? I've already shown you that, but let me show you really quickly again what that curve would look like. This is far more accurate if you're going to show both force relationships between two protons. Here again, using the pointer, you can see that essentially we have the same curve over here, where you see this is attractive force because it's below the line. But instead of going asymptotic here below the line, which is what the other diagram shows, correct? There's the Bošković force curve. There's our other curve. So you see here, it goes asymptotic below the spaceline. But in this diagram, it does not do that. It intersects the spaceline and shows repulsive force. It intersects the spaceline here and then shows repulsive force asymptotically to infinity. That is correct. That is correct. So this diagram that we have been looking at, that's the Bošković force curve, we're getting to that. This is incorrectly drawn, and there is no excuse for that. So Wikipedia has simply believed what the goddamned particle physicists like to say, and they're really irresponsible for that. They're simply encyclopedists. They have to depend on what the experts say. Never do that. A scientist cannot rely on what another scientist says. What a real scientist relies on exclusively is what that scientist can prove to himself. And that's what I'm going to be showing you concerning imaginary space. So we get a definition for it. And this will involve infinity, which has never been defined. Accept that because it's true, because I say so. I will circle back to that to make sure that you can verify that in your own mind for the reason I just said. You simply cannot believe what a man says. You have to be able to prove it to yourself. That alone is science. Okay, I hope I've given a good sermon there. That is rock bottom. There's no arguing with what I just said. And a lot of scientists, really most of them, statistically all of them except me, okay, I don't want to go that way because I don't want to invoke my emotional system. So this is incorrectly drawn, but you can pretend that it's true because this part of the diagram where it looks like it's an asymptotic relationship, simply disregard that because I just proved to you that it's not true. So that is not true. However, you can see by a quick comparison. There's the Bošković force curve, we're getting to that. You can see by a quick comparison that, using the pointer again, here's the curve of binding energy. This is attractive force, but at the 3 femtometer range, it crosses the spaceline, and this is actually true, and then turns into charge force, which is now dominant. And therefore their repulsive force takes over. But if the proton is inside the 3 femtometer range, a different force takes over, which used to be called the strong force, but that has changed meaning according to chromodynamics, quantum chromodynamics, of whom perhaps the greatest proponent was Richard Feynman. So we do not accept that definition. It's purely mathematical. This is geometric, and this alone is true. So this should be called the strong force, but alas, I'm not allowed to use it. As a reputable scientist, I cannot use a term that has changed meaning unless I explicitly state which I mean, and I'm outnumbered. So I'm forced to change the definition to not the curve of the strong force, but the curve of binding energy. More completely stated, and I must be rigorous here, it's the curve of binding energy between two protons, not a proton and electron. That would be this curve. But this curve shows both forces divided at the 3 femtometer mark. Okay, so far so good. So what I want you to see in this force relationship is that most of the curve is attractive force, but it reverts to repulsive. Do you see where? Of course you do. The repulsive force takes over right here at 0.8 femtometers. So between 0.8 femtometers and 3 femtometers, as you now know, that is attractive force. And that is the only range between two protons where they attract. So now I draw your attention, using the pointer again, and following the force curve. This is increasing attractive force. And it reaches a maximum right here. Okay, there's been a helicopter, there's been a siren, and now there is a jay squawking at a hawk. I'm not going to put it on pause anymore. Our local jay squawking either at a cat or at a hawk. She won't stop. I just took a nanosecond, I apologize, to slam the front door, and now the temperature will start to go up to 100 degrees, so I'm going to have to quicken my pace no matter what my natural cadence might be. I'm pouring sweat right now. I hope you can't see that. All right. We are now using the pointer to follow not the path of the proton, but the slope of the force relation, where it's at a maximum at almost exactly 1 femtometer, and then it starts to diminish until here at the intersection, which I'm circling with a pointer, there is 0 force between the two protons. That is extraordinarily significant. Why? Well, you might say it is a unique point on the graph, but it has extraordinary geometric, mathematic, and physical implication, which I am now going to explain to you at all 3 levels, but not at once. Mathematics is at the bottom. Contrary to what you might have heard said, or seen demonstrated by the clique, the cadre, really the mob of mathematical physicists who now are the only physicists there are. It's pure mathematics. That is a trap, as I will be showing you. We now can see that this curved line below the space line shows attractive force, and above the line where I am now pointing, that is repulsive force again, which also occurs beyond the 3 femtometer range, contrary to this stupid diagram which Wikipedia mistakenly published. They should be chided, perhaps even taken to court. I'm just exaggerating for effect. This diagram is completely misleading, but only if you are a nitpicker, I suppose you could say. it still works as long as you disregard this part of the graph, which is completely misleading because it says that the protons attract to infinity. They do not attract to infinity. This blue line crosses the space line and goes above it, and then goes asymptotic from above, showing repulsive force to infinity. Okay? I hope I said that enough times. There it is. That's the last time we'll see that. There's the Bošković force curve, which is a multiple curve showing the relationship between a proton core and the electron shells, plural. This isn't even a shell. This occurs at the boundary of the nucleus. At the boundary of the nucleus. At the start of action, when the inertial proton is somewhere on this line, and I pray that I'm using the right pointer here. All right. If the proton is in this range, it's being attracted. But if it has velocity, and it would if we just started action, it would start drifting slowly, at first infinitesimally slowly, on a quantum jump, on a non-tempescule. We'll come back to those fancy terms. It starts moving immediately with no lapse of time. That's very important. So without any intervention of time, if you start action, this proton immediately moves the smallest distance in the universe, and that is imaginary. So it makes an imaginary motion for one, we're going to say, absolute tempescule. After that, it gains velocity. It gains velocity. And the slope of this curve shows acceleration. Acceleration. It's not just being pulled. It's being accelerated. I hope you know Newtonian dynamics. Those are two completely, although they're related, but they're completely different descriptions of motion. Velocity is linear, but acceleration has a different relationship that is geometric, and now you can see the geometric relationship between velocity and acceleration. This curve defines it in physical space. So this is a very, very important curve. You'll see that the curve changes valence. The inertial proton is accelerating, and it continues to accelerate until it reaches the 1 femtometer mark, at which point it is still accelerating, but now the acceleration of the acceleration is at maximum. So the acceleration of the acceleration changes at this nadir. And now the proton is still accelerating, but the acceleration of its acceleration is slowing down. There's a mathematical term for what I just said, but I cannot pause to explain everything. This must be swift. So here, the proton, from the 1 femtometer to the 0.8 femtometer range, is still accelerating, but its acceleration is decelerating. That's correctly stated. Rewind this if you have to. I can't pause to explain what I just said. I hope you get it. So now the acceleration is decelerating, but the proton is still accelerating until it reaches this crossroads, at which point it is no longer accelerating. All it has left is Newtonian velocity. That is the residual velocity right here where there is no force relationship at all. In other words, the protons are no longer affecting each other in terms of velocity. So this now has its own velocity, which takes it closer than 0.8. And at the first instantaneity, the first tempescule of time, when it crosses right here at this point, and it is a Euclidean point, as soon as it crosses that point, it makes another quantum jump. It jumps from acceleration to deceleration. Stare at this until you get that. But I can't pause for you to stare at it. Just put this on pause. So the proton is accelerating until it reaches here, and in one quantum jump of no time at all, it changes from acceleration to deceleration. And only at that point is there no acceleration or deceleration. Only at that point is there no acceleration or deceleration. But the proton still has velocity. So it continues and immediately encounters a repulsive force of infinitely infinitesimal force. Infinitely infinitesimal. So I've named 3 impossibly tiny moments and 3 impossibly precise positions. They don't exist except in imaginary space. That is critical that you understand what I just said, but you don't. And I know you don't, so hold on to your horses while I explain all of that. Now the proton is still going forward and it's decelerating. How far does it get? I will now draw a line. Look at the line. It begins up here and goes down like this. It's an imaginary line, although it can be drawn. It's a precise line, a vertical line that is asymptotic to this curve, going up. It's asymptotic to that line to the same proportion that this curve is asymptotic to this line horizontally. Those are perpendicular asymptoses. Except that for now, I know that that does not make sense unless you're a genius, because it does make sense. But it's up to me to make sure that you can prove this to yourself. So when the proton continues, it can only continue 1/10 of 1 femtometer, perhaps a little more, but no more than 2/10 of 1 femtometer, at which range it encounters, and listen carefully, infinite repulsive force. That is a contradiction in science, in physics, akin to the ultraviolet catastrophe. I can't explain what that is, but that's what Max Planck was dealing with when he discovered the quantum of action. So this is all to do with quantum mechanics at its core, at its definitional basis, which no man has yet reached. I reached it, and now you're going to reach it too. And this is going to stretch your mind, and depending on what kind of exaggerated terminology or metaphor you wish to use, it's going to blow your mind, snap your mind, break your mind, or, as is the goal, and this will be achieved between you and me, it will expand your mind into a new space called imaginary space, which I discovered is physical. So how can I prove that to you? You may already intuit the proof, but this becomes absolutely precise in geometry. I discovered the geometry that explains the collapse of the wave function and the quantum of gravity. That is called the unified field solution, which Einstein sought and failed to reach. It is also the definition of the answer to the problem that Paul-Édouard Maurice Dirac said is the one and only and the last problem that needs to be solved, in which case everything will be solved. So this solves Paul Dirac's paradox that he posed to us before he died. He failed. Einstein posed it in another way. He died a failure. You're going to be a success beyond that of Dirac and Einstein, because I got it and I can prove it. So that's what you're tuned in to hear. And we will get to that in the next video, but we are approaching an hour. Normally I would go on another 2 hours, because that's my pace, that's my cadence, that's my rhythm, that's my natural cycle. That is beyond the reach of a normal human. It's just the way my mind works. Your mind cannot work that way unless you're like me. You're not. So let's just do it the way it has to be done, with me struggling to show you how you can catch up with me. That's called science. That is called communication. And that technically is called a proof sequence. And that is the basis of communicable science, is a proof sequence that you can do. You can't do that with space-time, and you can't do that with quantum mechanics. Nobody can, but I can. And I can do both simultaneously. This will involve my greatest discovery, perhaps, although there are dozens of them now, the discovery of physical imaginary space. And this involves the definition of infinity for the first time in the history of science. The actual definition that eliminates all the paradoxes of every known form of infinity. This solves them all. So this is a monumental breakthrough at all scales, at all levels. It goes way beyond physics. It covers reality and consciousness and the universe and everything humanity has ever wanted to know at all scales, to philosophy, even to religion. We can't go that far, not even in the next few videos, but I'll get there, as I have in the past. I've been practicing at this for 4 years. Strictly speaking, for 3 years, because I didn't discover the Bošković force curve until 1 year into this video channel lifespan. So far 4 years, 1,700 videos of practice. During that time, I have made dozens of major discoveries that change science at all levels, including a new mathematical basis, including a new geometry, including the definition of curvature, finally getting a definition and useful definition of the calculus, solving the problem of why are we using complex numbers. I can define that and get rid of them, and the calculus. None of that matters anymore. Once you switch to the right number system and the right geometry, which is a step up, which is going to blow your mind, snap your mind, you'll lose your mind, but nobody yet has lost their mind and not come back. You'll either give up in disgust and either hate me or forget me. But if you get this, you have the answer that Einstein sought, the answer that Dirac sought, the answer that nobody after those two men even bothered to try to seek. They've all given up. And what they call their dilemma is theoretical physics. Mathematical physics, they're dead in the water and they'll never get out of it. Science is halted. Not here, it's not. So what is the proof sequence that you need to see to show what I'm talking about when I say I've discovered physical imaginary space that leads to the definition of infinity for the first time in human history? What does that even imply? It means that I can define the collapse of the wave function so that you can actually see it, and you will then know exactly what is the quantum of gravity, which actually, believe it or not, has already been discovered, but nobody knows that it's been discovered. The collapse of the wave function is completely different, but the two problems are related conjugally. There are two infinities on this graph, although you've noticed that I've already pointed out at least three. There's actually a middle infinity here at the nadir. There's an infinity over here on this asymptote, and there's an infinity on this asymptote. And I was using the wrong pointer. Let me do that again. There's an infinity here at the nadir, which I described, there's an infinity here on the asymptote, and there's another infinity here on the conjugal asymptote. These are perpendicular asymptotes. What two quantities are perpendicular? They are energy and space. And that replaces the Einstein formulation of gravity. It's not space and time. It's space and energy. That's a major discovery all in itself. We'll go into great detail in the next 10 to 100 videos, but I'll try to limit it to 2 more. But we have reached an hour, and my room temperature has reached 100 degrees. I am pouring sweat. So sorry for the audio interruptions from the helicopter, from the siren, and from the squawking jay. But that's life. Always give precedence to life. If you're involved in something very important in science and you're interrupted by life, I don't care if you have to urinate, that's life. Or if your wife comes in and needs you, your girlfriend, or even your dog or your cat, you give attention to life and come back to your science, or you're just going to be missing out on the best part of your existence. Science is shit. I will show you, though, that this discovery of physical imaginary space unlocks religion. That will be my greatest achievement, after which I will be very happy to drop dead. But as long as I have breath, this is what I'm going to do until I drop dead. But it will go to religion, because that's all you need to care about. If you just care about science, I have no words foul enough to describe your fate. You're cheating yourself if you think science is going to bring you answers, except when you listen to me, and I'll show you the union of science and religion. And it doesn't make any difference what you think about God, Jesus, the Bible, Buddha, Muhammad, or anybody else. This is the basis of all those religions, because it's the basis of reality, and I will show you that this imaginary space, which is physical, is supernatural space. And if you don't like it, it's because you've been brainwashed, and there's no way out for you. You're a trapped rat, and nothing can save you because you're damning yourself. That's the law. Thank you for tuning in to Intergalactic. I hope I didn't scare you. This is the greatest news that you will ever hear. Yes, the gospel. We'll be right back. Thank you.